And now I'm going to pass it over to Nathan to give us a brief update on some exciting news.
Hi, everyone. My name is Nathan Harvey. I'm a developer advocate here with DORA and Google Cloud. As you can see on the slide, DORA is coming to DOES. Well, what does that mean? So DOES is the DevOps Enterprise Summit. It is a 3-day conference that's being held at the beginning of October. We're going to run a pre-conference event for you, for the DORA community. So we're having a half-day DORA Community Summit on Monday, October 2nd. We hope that you'll be able to join us. You can join for the entire conference for DevOps Days, DevOps Enterprise Summit and the DORA Community Summit. Register at that link, and then make sure that you check out the chat. I hope to see you there, and I'm happy to answer any questions that you have about it in the chat. Drop them there. Thanks, Amanda.
Awesome. Thank you, Nathan. Very excited. I know it's not everyone will be able to join us there, but it'll be exciting to have some of us together in person to have great discussions.
Hi, everyone. I'm Rob Edwards. I'm based here in the UK. Huge fan of DORA and have been for probably 6 years. I have the privilege of working with lots of our Google Cloud customers here in the UK and across EMEA, and really happy to welcome Matthew to this Lean Coffee session. And I have to apologize to him. I still feel guilty for how we initially started the discussion for having this session. We're both at the FastFlow conference in London this year, passing each other. Clearly, Matthew's more popular than me because he was always engaged deep in the conversation. I was always looking lonely with a coffee in hand. But anyway, when the opportunity finally presented itself to have a conversation, it was as we were both leaving, about to navigate London rush hour. So we had our chat and went our separate ways, which coincidentally happened to be the same location of King's Cross train station. And as it turned out, we were jumping on the same train. So we could have had a nice, relaxed conversation at the station. But anyway, enough of my rambling. For those of you who are not familiar with Matthew Skelton, he's the co-author of Team Topologies, organizing businesses and technology teams for FastFlow. He's been recognized multiple years actually by Tech Beacon for one of the top 100 people to follow in DevOps, and currently head of consulting at Conflux. The title of today's session is Untangling Software Delivery with Team Topologies, Flow Metrics, and Careful Decoupling. And the plan is to explore techniques and metrics to help you untangle software delivery by applying Team Topologies and other related approaches to decouple teams and ultimately improve flow. And one of those approaches being DORA as well. So I'll hand over to Matthew to get into the more detail.
So yeah, thank you to Rob, Nathan, Amanda, and the DORA team for inviting me today. It's great to be able to share some experience and some insights and things around this topic. Right, here we go. So yeah, I'm founder at Conflux. I'm co-author of the book Team Topologies. You find me online on LinkedIn and Mastodon. I've left Twitter for obvious reasons. Team Topologies book was published in September 2019, and that's nearly 4 years ago, which from my perspective has gone very, very quickly. But it's actually given enough time for lots of organizations to start using it, and we'll see a couple of those organizations later on. The book has won several awards, including it was in the top 10 best product management books of all time a couple of years ago. And it seems to continue to be making people's lives a bit better in the IT industry and beyond the IT industry, actually. The Team Topologies is the leading approach to organizing business and technology teams for FastFlow, providing a practical step-by-step adaptive model for organization design and team interaction. Bit of a mouthful, but what's involved in that? Well, what we end up doing with the Team Topologies approach is continuously untangling business concepts, because it turns out, obviously, most software, as soon as you get above the kind of level of firmware and devices, when you're writing business software, software is just an encoding of business concepts. If software is tangled, it's almost certainly the case that the business concepts themselves are tangled. So we look to focus on untangling right at the kind of top of the funnel, if you like. So a lot of the time we're thinking about finding and adjusting team and system boundaries for fast flow, which is not something that historically happened particularly. We're looking to minimize handoffs. We're looking to avoid blocking dependencies. We're moving some decision-making to teams. Now, all of this together, what it does, Team Topologies effectively exposes any lack of clarity in purpose or conflict in priorities or a misalignment of incentives. So that can be kind of interesting to see when we start to apply that inside organizations. But But ultimately, we're aiming towards more effective organizations that are more nimble and more adaptive. The talk today looks like this. We'll look at the cost of tangled software. We'll look a little bit then about DORA metrics and Team Topologies, how that can help. We'll look then at some real examples of detangling, and finally, like how to get started, a few ideas, techniques, and so on to use. If you've only got 5 minutes, then here is a summary of the talk. There we go. You can leave now. It's all about flow. If you want something a little bit more involved as a summary, this next slide is slightly more expanded. So use balanced health metrics like the DORA metrics, flow, cost, blockers, and so on, plus some Team Topologies techniques, which we'll look at later, to help find good boundaries for fast flow by untangling and decoupling separate services. So that's the kind of summary of the talk, and as we'll go through the next, whatever it is now, 15 minutes or so, start to unpack some of this. So let's look at the cost of tangled software. Now, by tangled software, this is where we've got lots of weighting and dependencies between different parts of different teams and different people in the organization building this stuff. That's what I mean by tangled. So let's do a little bit of a calculation. This is properly like back of an envelope calculation stuff. It's not very refined, but it's just to paint a bit of a picture. If each engineer in the organization is blocked for, let's say, 1 hour per working day, how much does this cost? And that's actually a modest amount. There are organizations where, if you look at it in some detail, each engineer will be blocked for the majority of their time. But let's be generous in this particular case here. They're only blocked for 1 hour a day out of an 8-hour day. And the fully loaded cost of that engineer, let's say, is about 160,000 euros. I mean, it varies, right? But let's just say that's the fully loaded cost. So salary plus benefits and everything else. They've got about 260 paid days a year. Let's say there's a total of 400 engineers in that particular organization. So not huge, but also not tiny. If you do the maths, it's about 8 million euros a year, which is pretty staggering, right? If they're only blocked for 1 hour a day. And they're blocked, let's say, because of the way that they're having to wait on another team to do something. So the numbers get pretty large quite quickly. So let's look into this a little bit more. We'll come back to this later, but let's look into the detail a bit more. When we say untangling, we sort of mean something close to what people say mean by decoupling. Decoupling is separating things that do not need to be together. We're not talking about decoupling everything. It's just find the stuff that does not need to be together and take it apart. Some things do need to be together. We need to couple them, like these train carriages, but other stuff doesn't. And if we get the decoupling effective in a good place, it enables a shorter time to value. It also enables multiple independent flows of change, each with its own cadence. So we've got these multiple different flows. They've got their different side services. They're going at different speeds. And that's what we want. We're not trying to bring everything together and deploy it all at the same time. So we've got a need to decouple teams and technology. Now we've got to balance that by a mingling of ideas for learning. It's got to be, we're not decoupling absolutely everything. We're decoupling the more technical parts and we're allowing the more human parts to still be more shared. But we're certainly decoupling teams, software, technology, deployments, data, business concepts, and this kind of stuff. We are looking to mingle principles and practices and learning and techniques and approaches. Is that partly what we're doing today? We're mingling these ideas here by sharing it in the community. I'm just going to drop in a quick side note. There's a really, really interesting topic which is not really covered very much, which is actually how to decouple for reliability. Because if we do this well, not only do we get decoupling that helps with fast flow, but we actually get decoupling that helps to reduce the number of ways in which software can fail. It actually helps us to understand and reason more about failure modes. So this starts to touch on SRE or reliability engineering. And it certainly, decoupling can help to prevent cascading failure and also kind of contain the blast radius when a problem occurs. So what do we mean by that? It's like these are actually containers where you put a bomb inside or a suspected bomb inside one of these containers, and so you can then it contains that blast. Here's a photograph of, I think this is the FBI outside, I don't know, it's a bank somewhere or outside somewhere in the US, and that's actually an actual like explosive containment chamber. That's how they deal with a live bomb. decoupling actually helps with some of that. It helps to contain the kind of blast radius of potential problems rather than having cascading failures across a huge part of the system. We're not going to talk much about that. Maybe we can talk about that in the coffee. I think it's really interesting. It's not often brought together, those two different worlds of software engineering, but I think it's going to be increasingly important as we build bigger and more complicated systems. So part of the decoupling that we're talking about today has this nice side effect, if we get it right, of actually helping us to build more reliable and fail-safe systems. Okay. I think so. We've got some tangled systems like this. They cost whatever. It costs like 8 million a year for a very modest amount of waiting time for 400 engineers. What can we do about it? Well, let's have a little look. We've got the 4 key metrics from Accelerate, and we can add something that I'm calling here blocker count. As you'll be aware, the book Accelerate was published 2018 by the same publisher as the Team Topologies book. That's IT Revolution. IT Revolution are the organization that run the does conferences as well, DevOps Enterprise Summit, that Nathan mentioned earlier on. And there's 4 key metrics for Accelerate, which you'll be pretty familiar with: lead time, deployment frequency, mean time to restore, and change fail percentage. These are the 4 key metrics that indicate high performance in organizations. It's worthwhile remembering what these are doing. There's 2 metrics here that encourage fast flow: lead time and deployment frequency. But fast flow by itself is not enough. It has to be sustainable fast flow. And to make sure it's sustainable fast flow, we actually need to make sure that the stuff we're deploying works well. So, of course, it's balanced by these 2 metrics that encourage operability: mean time to restore and change fail percentage. And that's why these 4 metrics are so nice to use. And it's been such a gift, really, to the industry to have these as a kind of foundation, as a starting point for thinking about and starting to improve the quality and approach to software delivery in general. So we can use these. But there's actually something else we can look at, which is flow efficiency. And this relates back to that initial state that we talked about, where there's 400 engineers and they're kind of blocked for an hour a day. What's the percentage of lead time is actual work? So you might have a certain kind of lead time. That's one of those the key metrics. But what percentage of that is actually doing real work, and what percentage of that is actually waiting on other teams? And it turns out in many organizations, the flow efficiency is very low, because the amount of time we're spending doing work is actually like a minority of the total amount of time of our lead time. So in many organizations, flow efficiency is down at 16%, something like this. This is just an example, but it's very low. Like the majority of the time across the entire organization, people are actually waiting on other people to do things. And that's financially inefficient, as well as being inefficient from a flow perspective. So there's value in trying to improve the flow efficiency metric. Well, you can maybe start to measure the waiting time between different useful bits of activity. Turns out that actually measuring wait time is pretty hard. In theory, it's a straightforward measure, but in practice, it's actually quite difficult. So actually, a proxy measure is just to count the number of blocking waits. So just count the number of times that you're blocked and you're waiting on another team to do something or another person to do something. And just that number is a good enough proxy, it turns out. So then we end up with these 4 key metrics and the blocker count as a kind of proxy for flow efficiency. Now, all fine and good. I'm sure many of you on the call now are doing this stuff already. However, what we found is that you can use these 4 key metrics and blocker count to assess and find better service and team boundaries for flow. So, for example, you can have conversations like this: hey, if we adjusted the team and service boundary in this particular point, would it actually improve the 4 key metrics? So if we as a team took on responsibility for something else, so an additional part of Kubernetes configuration, or we took on additional bit of configuring the deployment pipeline, or whatever it is, could that improve these metrics? Let's try it. And so that starts to suggest an adaptive approach to where different kind of service boundaries sit, because we're now thinking about flow and ownership of these services. Likewise, if we adjusted the service and team boundary here, would it reduce the blocker count? Would it reduce the number of times we have to wait on another team to do something? So we're taking on something more, or we're asking another team to provide something as a service, maybe in a better way. Which is kind of an interesting way of using these metrics. It's not just about trying to optimize the metrics. We're using the metrics to do something else, to improve flow, and as a way to have a conversation with other teams across the organization. There are also some techniques from the Team Topologies community that are useful in this space. There's something called independent service heuristics, which I developed or co-developed with various people, but starting back in early 2020. So independent service heuristics are rules of thumb or clues for identifying candidate value streams and domain boundaries by seeing if they could kind of conceptually be run as a separate SaaS or cloud product. Now, the technique is Creative Commons. It's like open source, if you like. You'll find the details on the Team Topologies website there, teamtopologies.com/ISH. But in principle, what it is we identify a set of candidate value streams, and then as a group of people with a mixture of perspectives, we go through and use a series of 10 kind of questions or dimensions to talk through and assess whether a particular area is maybe a good candidate for separating off as a separate value stream. And obviously then we would start to use some metrics and things like this to give us confidence that we've found a sensible boundary. But it's quite an interesting technique, and you end up with a heat map of opinion and experience around potential candidates for separating off. We've been using that now, like I said, for 3 years, and developed it into quite a useful tool. And it's quite refreshing and interesting to see that it enables conversations across the organization. You can have people who are not technologists at all. They're like head of product, or they're head of retail warehouse, a physical warehouse with goods inside it, or head of strategy. And all of these people together with IT engineering and database people and whoever can come together and have a conversation about where viable service boundaries might be. So it's a really interesting technique to see in action. Another technique that's related is called user needs mapping. And again, this is an open technique. User needs mapping attempts to capture the first 4 steps of the Wardley mapping process for identifying potential team and service boundaries. So Wardley mapping is for strategy. We're trying to map when and where we should invest in building certain things and where we should just expect to consume it from the outside, and so on. And what we're doing is we're kind of using part of that Wardley mapping technique to think about where team boundaries might sit in relation to user needs. So we put these user needs at the top of the diagram, and then we kind of try and assess where a viable team boundary might sit. There's another technique that helps us to consider boundaries for fast flow. This is the point. The point of this stuff, the whole Team Topologies book is about organizing business and technology teams for fast flow. That's the context. We don't want any handoffs. We need to have end-to-end ownership, responsibility, and so on. So again, you'll find more details on user needs mapping on the Team Topologies website, teamtopologies.com/UNM. And finally, there's another technique I want to share with you called team interaction modeling, TIM. And team interaction modeling helps to describe how to reorganize teams and their interactions to achieve better flow and deliver value faster. You've probably maybe seen some of these Team Topologies diagrams. They all have a flow of change left to right, because we're thinking about flow. We're thinking about end-to-end ownership, and that's why the diagrams look like this. And as we're changing our organization from its current position into something that's more flow aligned, we can then start to use this diagramming technique, this interaction modeling technique, to help us explore options for different team boundaries and how that might relate to different kinds of flow. teamtopologies.com/TIM will get you to the details there. And it's a combination of these kinds of techniques together with metrics that really give teams, managers, architects, and so on, the confidence and the language to talk about adjusting boundaries for better flow. And it ends up being really powerful. Let's have a look at a few examples now. The first one comes from JP Morgan, the financial folks, the investment company, and so on, banks. And there is a great case study. Rob earlier on mentioned Fast Flow Conference. It happened earlier this year in London. Super awesome event organized by practitioners who are interested in Team Topologies, and they've put all of their videos on YouTube. And this particular one is called How JP Morgan Applied Team Topologies to Improve Flow in the Market-Leading Enterprise Platform. You'll find the link in the slides. And I highly recommend watching this talk. There's 3 different presenters. The presenter you see in the middle here is one of 3. And I'll just zoom into that slide there, because it's quite an interesting diagram. If you look on the left, this shows their team interdependencies in terms of delivery before they started applying Team Topologies principles. And then the diagram on the right-hand side, 1 quarter later, shows the resulting interdependencies. They've significantly reduced the team dependencies. In fact, they actually said that 60% of dependencies were reduced through better team design. And that's a significant improvement in terms of flow efficiency and therefore in terms of financial efficiency. If you remember this stuff we had before, so a simple calculation might result in like 400 engineers cost with one blocking hour per day costing like 8 million. So that's not a number that JP Morgan applies to JP Morgan. This is a number that I've invented, but the point is that they would have done a similar calculation and come up with some kind of figure which made them realize they need to invest in this approach to decoupling and adjusting boundaries using some Team Topologies principles. There's an interesting case study on the Team Topologies website from a company called Wealth Wizards. They're involved in the kind of pensions and the personal investment space. You can read more about it there, but they were having really good growth, and then everything ground to a halt in the middle of 2019, and they couldn't deploy. Everything was coupled, and so on and so on. Conveniently, the Team Topologies book was published a couple of months later, so they jumped on that and started to use the ideas. We actually used an early version of independent service heuristics, I think it was early 2020 with them, and that helped them to think through some different options and to adjust the boundaries for flow. And so they ended up having a diagram that looked like this, which is using some of the Team Topologies diagramming colors and shapes and things to help them think through where the different boundaries would be. And so the CTO at the time, Richard Marshall, said Team Topologies gave us the tools we were looking for and to help us to build a plan and have confidence that we know where we're going and how to get there. And crucially, you can see on this concept here, they were focused on boundaries that help flow. That's one of the things that they really took to heart, that helped them get out of that mess, effectively, or that difficult situation where everything was coupled. So yeah, quick thank you to Richard for allowing us to share that. And there's more details on the Team Topologies website. If you go to teamtopologies.com/wealthwizards, that'll redirect you to the full case study that's online there. There's another nice example here from the UK Government Home Office. I spent most of 2018 at the UK Government Home Office as one of the engineering leads, or is the engineering lead for that particular program of work. And there's a really interesting public article called this, How the Home Office's Immigration Technology Department Reduced its Cloud Cost by 40%. It's a great story. I worked alongside the people who did most of the work there. I wasn't involved in this specific bit of work myself, but we saw each other every time we were in the office. We did a lot of other work together. And you can read it. It's online there. It's a good story. And there's a really cool thing they did with these kind of EPC charts. It helped teams to find ways to reduce their cloud spend. It's a great story. If you're interested in that kind of stuff, have a look. But there's a thing that particular article doesn't actually talk about, which is something that I saw when I was there. And what happened was that as service owners became more accountable for the costs of their service, they took a greater interest in delineating, in separating what was their service from what was somebody else's service, particularly if you got data storage and other kind of costs, maybe logging and things like this. They became much more focused, as you'd expect, on saying, well, actually, this is my service. This is the stuff that is just for me. And then this is not my service. So actually, what was really interesting was making service owners accountable for the actual dollar spend for their service helped to clarify and shape the service boundaries. And what it looked like to me was the cost metrics were a kind of financial scalpel or knife to split the services apart to get better flow. And it's a super interesting thing to see happen and play out. And this is effectively a bit like financial engineering that you might be able to do. It's a little bit like FinOps, but you can do it. You don't need to be in that kind of. You don't need to be in using serverless or whatever to do it. You can start to do it in your context now. Okay, a few more ideas on how to do this. It's really important to track dependencies and separate as blocking versus non-blocking dependencies, because dependencies are not a bad thing by themselves. If those dependencies are, if we can serve those dependencies, if we can consume them from a service and they don't stop us doing what we need to do, that's actually quite a good dependency because we don't have to think about it. Dependency is bad if they become blocking, if we have to wait on another team or another thing to happen before we can move ahead. So we want to be looking to turn blocking dependencies into non-blocking dependencies where we can. The general principle for better flow. We can also use tools like CodeScene to detect hidden coupling. CodeScene is an awesome tool. Here's a screenshot. So measure how well your organization aligns with your architecture. It's an amazing, like, I wish I'd written this software basically. You'll find more at codescene.com, but it's actually, the tool itself has been inspired by aspects of Team Topologies. We were inspired by aspects of that tool when we were writing the book. And in the screenshot here, it's talking about architecture and Conway's law and temporal coupling and stuff like this. It's amazing to explore your code base and see how it relates to the teams. You can use the tool like this. This is the best tool I'm aware of in the space. Use tools like that to find maybe better boundaries, or where this tool thinks that boundaries already exist inside the code base. We can start to lean on tools like this to give us more insights. There's a team dependencies tracking tool on GitHub. It's very simple. Again, it's Creative Commons. It's inspired by some details from Spotify. You'll find it on our GitHub repository at github.com/Team Topologies. And it's relatively straightforward, but the point here is that we start to think about what these dependencies are and track them as, are we blocked right now? Are we likely to be blocked? Look at which teams are causing the most blockers, if you like, which teams have the fewest, and so on. It gives us some perspective on where to have conversations and where to look at next. So we can use this team dependencies tracking approach to find and remove dependencies that hurt flow. That's the key thing. If there's a dependency there, but it's not hurting flow, then in this context of fast flow, we might not care so much. There are also some other tools, things like Team Form, where you can look at your organization through the lenses of teams and bringing in other kind of data. But tools like this are really interesting. We're seeing more and more of these kind of tools pop up, where it's taking a kind of socio-technical view of the organization, thinking about code and systems and teams and how they interrelate. Okay, we looked at these 4 things here. The cost of tangled software. We've looked at the DORA metrics, and Team Topologies can help. We've seen some real examples, and then a few pointers about how to detangle. If I were a salesman, I would say this: you too can save €8 million per year by decoupling for fast flow. But thankfully, I'm not a salesman. At least that's not my profession, so I won't say this. But you get the picture, right? There's an actual financial cost to tightly coupled software. It means we can't have flow. People are waiting. That you can point your chief financial officer to this kind of material, and that it'll get their interest. So here's a summary. We're looking to use balanced health metrics like DORA, flow, cost, blockers to flow, plus some techniques from Team Topologies like independent service heuristics, user needs mapping, team interaction modeling, to help find good boundaries for fast flow by untangling and decoupling separate services. So I'm going to stop there. I'm super interested to find out about your perspectives and which aspects resonate and which things feel incorrect in the chat coming up now. So thank you very much.